Good morning to everyone. In this lecture, we are going to discuss about first unit in our subject power electronics, that is power semiconductor devices and commutation circuits. In this, we mainly going to discuss about what are the different types of power semiconductor devices, working and characteristics of these power semiconductor devices. Similarly, we are going to discuss about what is commutation, what are the different types of commutation, and what is the working of these different types of commutation circuits in detail. These are the main outcomes of this lecture. That is, what is power electronics? What's the use of power electronics subject in BTech course? And what is converter? What are the different types of converters, types of power semiconductor devices, and introduction of SCR? We are going to discuss these topics in this lecture in detail. Coming to power electronics, generally power electronics is the combination of three types of engineerings. In that, first one is the power engineering or electrical engineering, second one is the electronics engineering, third one is the control engineering. By knowing these three types of engineerings, we can get the idea about power electronics. Now we are going to discuss about each and every type of engineering. Coming to concept of power engineering or electrical engineering, this is simply electrical and electronics branch in BTech course. It is defined as the engineering which deals with high amount of electrical power generation, transmission, distribution, utilization, and also deals with the high power equipments. Here high power equipments are nothing but motors, generators, transformers, etc. By using these high power equipments only, it can possible to generate the electrical power. This engineering deals with the electrical power and high power equipments for generating that electrical power. That is nothing but power engineering or electrical engineering. Coming to electronics engineering, this is simply electronics and communication engineering in BTech course. It is defined as the engineering which deals with low amount of power equipments. The examples for low power equipments are power semiconductor devices. Those are nothing but diodes, BJTs, MOSFETs, IGBTs, etc. In this engineering, that is electronics and communication engineering, we mainly concentrate on power semiconductor devices working and characteristics. That is nothing but electronics engineering. Coming to control engineering, the engineering which deals with static and dynamic characteristics of electrical equipments or electrical systems is nothing but control engineering. The examples for control systems are analog and digital systems. By using above analysis, we are going to frame the definition for power electronics. That is defined as the application of solid state electronics for control and conversion of electrical energy is the definition for power electronics. We already discussed about power electronics is the combination of three types of engineerings. In this, we are having three types of engineerings. That is, here solid state electronics comes under electronics engineering, and control comes under control engineering, and conversion of electrical energy comes under electrical engineering or power engineering. So this is the definition of power electronics by using above analysis. Coming to use of power electronics subject in BTech course. This subject, power electronics, is one of the major subject in 4-year BTech course, especially for triple E students. For triple E students, this subject is very important. Why? Because in GATE exam they will get 8 to 10 marks from this subject. And second one is Without power electronics concept, there is no mini and major projects in BTech. That is nearly 90% of the topic. That is mini and major projects topics having the concepts of power electronics. That's why we are going to concentrate this subject, power electronics subject. Up to now we discussed about what is power electronics and what is the use of power electronics subject in BTech course. Now we are going to concentrate on converter. What is converter? What are the different types of converters? Here converter is nothing but it is a circuit which converts one form of electrical quantity to another form of electrical quantity. That is simply it is a circuit. Converter is a circuit which converts one form of electrical quantity to another form of electrical quantity. Here electrical quantity is nothing but either voltage, current or power. It is a circuit which converts one form of voltage to another form of voltage, or one form of current to another form of current, or one form of power to another form of power. That is nothing but concept of converter. Now depending upon the type of the conversion, this converter circuits is classified into 5 types. These are the types of converters. In that, first one is a rectifier, second one is AC voltage regulator, third one is the cycloconverter, fourth one is a chopper, and fifth one is a inverter. Now we are going to discuss about each and every type of converter circuit. Coming to first one, that is rectifier. Rectifier is a circuit Rectifier is a circuit which converts AC voltage to DC voltage or pulsating DC voltage. That is, this is the rectifier circuit. For this circuit, we are going to apply the AC voltage as a input. Then we are going to get the DC voltage or pulsating DC voltage as the output. This is the waveform for AC voltage. We are going to give this waveform to the rectifier circuit as a input. Then we are going to get this waveform. That is, this waveform is the DC waveform. So this is the circuit. Rectifier is a circuit which converts AC voltage to DC or pulsating DC voltage. Coming to second type of converter, that is AC voltage regulator. AC voltage regulator is a circuit which converts fixed AC voltage to variable AC voltage at fixed frequency. That is nothing but the frequency at the input and frequency at the output is constant. Means we are maintaining the frequency is same, but we are going to convert fixed AC voltage to variable AC voltage. That is the concept of AC voltage regulator. Coming to third type of converter, that is cycloconverter. Cycloconverter is a circuit which converts fixed AC voltage at fixed frequency to variable AC voltage at variable frequency. The concept of AC voltage regulator and cycloconverter both are same, which converts fixed AC voltage to variable AC voltage. But in case of AC voltage regulator, we are maintaining the frequency as constant. At input as well as output. But in case of cycloconverter, we are going to convert fixed AC voltage at fixed frequency to variable AC voltage at variable frequency. Means here frequency is variable. That is the difference between AC voltage regulator and cycloconverter. Next type of converter is chopper. The concept of chopper is very simple. That is, chopper is a circuit which converts fixed DC voltage to variable DC voltage. That's the concept of chopper. Here fixed DC voltage means the voltage which is having the constant magnitude. This is the waveform for DC voltage which is given to the chopper circuit as the input. And we are going to get the variable DC voltage. Means variable DC means we are going to get like this. Variable DC voltage. This is the waveform for variable DC voltage, and this is the output of this chopper circuit. So chopper is a circuit which converts fixed DC voltage to variable DC voltage. These are the waveforms for fixed DC voltage, and this is the waveform for variable DC voltage. Coming to last type of converter, that is inverter. Inverter is exactly opposite to the rectifier. In rectifier we are going to convert the AC voltage to DC voltage or pulsating DC voltage. Rectifier is a circuit which converts AC voltage to DC voltage or pulsating DC voltage. This inverter is exactly opposite to this process. That is, inverter is a circuit which converts DC voltage to AC voltage. That is, for this we are going to give the DC voltage as the input of this circuit. Inverter circuit, we are going to get the AC voltage as the output of the inverter circuit. Okay, that is the concept of inverter circuit. That is about the concept of converter and different types of converter circuits. Now we are going to discuss about different types of power semiconductor devices. This concept is very important in gate point of view. Very important in gate point of view. Try to concentrate. Okay. Depending upon the control strategies, these power semiconductor devices are mainly classified into three types. In that, first one is a control on and control off. Means by using some control parameters or control variables, we are going to turn on and we are going to turn off the power semiconductor devices. The examples for this one is BJT, MOSFET, IGBT, etc. And coming to second one is exactly opposite to the first one. That is uncontrolled on and uncontrolled off. The example for this type is diode. And similarly coming to third one, that is controlled on and uncontrolled off power semiconductor device. The example for this one is SCR, that is silicon control rectifier. This is also known as Thyristor. Okay, this is the classification of power semiconductor devices depending upon the control strategies. Those are classified into three types. First one is the control on and control off. Second one is the uncontrolled on, uncontrolled off. Third one is the control on, uncontrolled off. Now we are going to discuss about SCR, that is silicon control rectifier. Total power electronic subject is depends upon the working of SCR. So try to concentrate more. SCR is the example for control on and uncontrolled off power semiconductor device, and it is also known as Thyristor. Coming to construction of SCR, SCR is a 4-layer, 3-terminal, 3-junction power semiconductor switching device. Coming to electrical symbol and construction, SCR is a 4-layer, 3-terminal, 3-junction power semiconductor device. Okay, these are the 4 layers of SCR, that is P, N, P, N are the 4 layers and 3 terminals. This is one terminal, this is second one, and this is the third terminal, and 3 junctions. This is first junction, and this is the second junction, and this is the third junction. So it is a 4-layer, 3-terminal, 3-junction power semiconductor device. The terminal which is connected to the upper P layer is called the anode, and the terminal which is connected to the lower N layer is called the cathode, and terminal which is connected to the lower P layer is called the gate. So these are the three terminals of SCR, and these two are the electrical symbols for SCR. Okay, both the symbols are correct. The difference between these two symbols are, here gate terminal is connected like this, in this gate terminal is connected like this. That's the difference between these two electrical symbols. Here the electrical symbol for SCR is same as the PN junction diode, but PN junction having only anode and cathode. SCR having extra terminal is gate, that is along with anode and cathode, SCR having the gate terminal. That's the difference between PN junction diode and SCR. This is the introduction of SCR. In the coming class, in the coming lecture, we are going to discuss about working and characteristics of SCR. Total power electronics subject depending upon the working and characteristics of SCR. Thank you.